Okay, so 2.6 is one of the, oh, more frustrating, deeper, um, more abstract sections in the course. So I have sort of borrowed a couple of things from different online sources. One is this sheet of parent functions. You do not need trigonometric functions for college algebra, but they're on the page already. This is certainly not the only kind of rational function, but what I'm really after here, this is a constant function. This is f of x equals x. This is absolute value x. Absolute value means distance from 0. So 4 and negative 4 are the same distance from 0, so they're the same height. This can also be called the floor function. It's just the integer portion of a value. So at 1, it's 1, but at 1.5, it's still 1. X squared, x cubed, root x, cube root x. This is an exponential, which we probably won't have pop up just right now. This is the log. These two are inverses, so they reflect each other. 1 over x. This is just, you should kind of recognize these shapes and be able to kind of make a guess that something is a cubic or a cube root or square root and so forth. Just kind of recognize them visually. So I posted that for you on the homework. Also posted this, which somebody else created, but which is pretty good. Basically, transformations, you have horizontal transformations and vertical transformations, and it all has to do with order of operations, how you deal with it. So the transformations after the original function, those are vertical. So they're kind of outside of f of x. So if you look down here, you've got f of x and then a plus d on the outside, a minus d on the outside. A number times it on the outside, and the same here. It's just a c we'll assume is greater in absolute value than 1, so that 1 over c is a fraction less than 1. Negative on the outside. So what happens when you have these numbers on the outside is they make a vertical change and they go kind of the direction you would want them to. So if I say, oh, add d, it's a vertical change. You want it to go up by d. If I say subtract d from the function, you want it to go down d if you know it's a vertical change. And it does. It does exactly what you want. If you multiply by something bigger than 1, say 9, you'd like it to get taller if it's going to be a vertical change. And 1 over c, if it's say 1 over 9, you'd like it to get shorter if it's a vertical change. And it does. A negative is always a reflection. So negative on the outside, it's a vertical reflection, so it flips over the x-axis. Now, what happens is that the ones before the function are the ones next to x. So because I would first, if I saw f of x plus 3 and then I plugged in 4, then I would do the 4 plus 3 first before doing the function. Same thing if I saw f of 4x and then you said x is 2. I would multiply the 4 times 2 first. Because remember, when we took whatever was in the parentheses and plugged it in, we left it in parentheses when it wasn't just a number. So its order of operations says do the parentheses first. So all that stuff we're doing first. So if I want to figure out how it transformed the graph, I have to undo it. So horizontal changes, which are the stuff inside the parentheses, are all exactly the dead opposite of what you would like them to be. So if you say, oh, horizontal change, add d, you'd like to go right. So instead you go left. If you say horizontal change, subtract d, well, you want to go left, so go right. If you multiply by 9, you'd like it to get wider, so it doesn't. It gets thinner. If you multiply by 1 over 9, you'd like it to get thinner. So it doesn't. It gets wider. Now, the reflection in this case, it's still a reflection if you do a negative. It's just that it's a horizontal reflection, so it's over the y-axis. Okay. So the thing also that people have started doing a little more heavily is doing a kind of t-chart and doing these transformations by hand and then plotting the new points instead of considering the shift. So because these are after the fact, you just add d, subtract d, multiply by c, multiply, and remember it's vertical, it's all on the y side. This one, it's all on the x side, so it's on the first component, and it's reversed. So if it's plus, it's negative, negative, plus, times, divide, divide, times. The negative is the negative. So this does things to x, the other ones do things to y. So if they're inside the parentheses, they're acting on x. Outside the parentheses, acting on y. So you can do it either way, and maybe we'll kind of try it both ways to see what works best for you, but you do have this document available to you. That's not what I want. Okay. So on this one, I started with 1 and skipped 8 every time. So this one, we're just looking for root x. This is root x. This appears to be cube root x. This appears to be x squared, absolute value x, x cubed, 1 over x. So root x. Oops. Skipping 8's just right here. Okay. We want x cubed minus 1. The minus 1 is on the outside of the function. It's not with the x. So it's a vertical change. If it's adding or subtracting, it's just a shift. So minus 1 goes down 1 because vertical does what we want. So we look for where the point, the little wiggle point should be 0, 0. So where it went down 1 is right here on C. Okay, 17. This, they're telling us, is y, and we want 1/3 of y. Because it's on the outside, it's vertical, so it does what you'd want it to, so it makes it shorter by 1/3. So the width will stay the same because it's outside y. It can't make a horizontal change, so we could rule out right away these two. But we want it to be shorter, so instead of 3, it should come down to 1, which makes it this one, B. Okay, 25, we want negative absolute value x. Absolute value x looks like these two. It does not look like this, so it has to be one of these. Because it's a reflection, this is regular absolute value x. The negative on the outside means it flips upside down, so it's this one. It flips over the x-axis, so it's D. Okay, now we have two things. There's a negative next to the x, which means it's a horizontal reflection, so it flips over the y-axis. But there's also a -6 on the outside. So the outside, -6 means go down 6. So we would have, let me just sketch this for you. We had root x, and then we want to reflect it. So we reflect it, and then we go down 6. So down 6. So reflect, down 6. And we should end up with something like the yellow one there. So here, D. Oops. Oh, I did not see that minus sign right there. Okay, so there's a negative on the outside also, which means it flips upside down. And that happens before the minus 6. You can imagine in your mind that you plug in a value. Say you plug in 0. First you would do this minus to it, then you'd do the root, then you'd do the minus, and last you'd do the negative 6. So the part that I skipped over here, let me just start this over. First we had that, and then we need to reflect it. So we end up over here. And then we need to reflect it again. So that we end up down here. And now we need to shift down 6. So that we end up here. Which now leads me to C. Okay, now 41, we're given y. We want to graph negative 1/4 f of 1/2 x. Take this over. Oh, hopefully I can see that. Well, we know that that's 1/4 and 1/2. Okay, so we have a negative, which would flip it upside down. We have a 1/2 x, which makes it horizontally doubled. 1/4 y, which makes it 1/4 as tall. So this is 4. Because it's several things, to try to make it clearer when I don't have you here in front of me to ask questions, I'm going to do it this way. So we start with 0, 0, 1, 4, negative 1, negative 4, 2, 0, negative 2, 0. Oops. Okay, so 0 for y, we have to do two things. We have to multiply them by a negative and a 1/4. So that stays 0. 4 times negative 1/4 is negative 1. Negative 4 times negative 1/4 is positive 1. 0 stays 0, 0 stays 0. So you could do it in 2 steps, but we have to do 2 things to it. One is multiplied by a negative and one is multiplied by a 4. On the x's, though, we need to multiply them by 2. So that's still 0, 2, negative 2, 4, negative 4. So the points now are 0, 0, 2, negative 1, negative 2. Here, I'll put all the hashes in there. Negative 2, 1, 4, 0, negative 4, 0, and it's still going to have that same shape. Okay, so let me take this with us to decide. So this one has negative 4, 0, 4. So it's got to be one of these two on the right. And on negative 2, I should have gone to positive 1, so it should be this one. And then the last one, we've got 1 over x as our basic function, and then we have this as the result. Oh, we want to try to make this one. Okay, sorry. First I thought we were trying to make that one, and since that is already 1 over x, that did not make sense to me. Okay, so to get from here to here, there's an asymptote here that's not sketched in because there's a solid line there, but there is one. It has moved over. So we know that the x's have gone to the right 3. Then you go over 1 and up 1, that's the same. To the left 1 and down 1. There's no indication at all that anything else has happened. So if this was up here at 2, then we'd have some sort of stretching. If this asymptote had also moved up or down, but it hasn't. So it seems that this is an identical graph moved over 3. So if all it did was move over 3, then we still have 1 up there, and we have x minus 3. Because remember, if it goes to the right, it's minus 3 because everything's backward when it's horizontal. Okay, so that wraps up this section.